actually got two jobs. I've got a fledgling startup that I call Authorization Hub, and it is a tool for ASP.NET Core applications that allow you to build up a organizational tree, and it uses the relationships in that tree to power authorization policies. So that's my first gig, and then the second gig is I work for Nimble Pros. It's a consulting company out of Ohio that was started by Steve Smith. You might know him better as Odalis. I started working there about a year ago, and it's a really great group of people. I've really enjoyed that. So a little bit of background about what I've done. But to the meat of the topic, I feel like we've crossed the Rubicon recently, maybe just last December or so, where agentic AI has become good enough that it's really going to change software developers, the role of the software developer. That notion that you can write software and just be an expert in some narrow vertical slice, some technical skill or some tool chain is probably going to end. And so I think we need to all kind of think about how our role will change, how we're going to develop a process that's going to leverage AI to get work done. And so I think that's going to be one of the big changes that we'll all experience. And you know, when you think about that, it makes you think like, what's my role in AI with this new process going to be? And so I started thinking about what are the advantages that the person has over AI. And I think that really, it boils down to all of those things that are about you, right? It's all your personalities, your experiences, your abilities. It's your ability to understand and communicate and influence people. And so I think those are the types of things that are going to be your advantage, because you're all special and you're all unique. And when I say words like that, I kind of start to channel that guy in the, go back. That guy in the red sweater, right? I don't know, maybe you guys are too young to remember Mr. Rogers. But I think, you know, he would say those same types of things. And I think when we talk about AI, a lot of people have this notion that like, it's going to be this death match between AI and humans, right? And I don't know if that's necessarily how it's going to be, but I think that's kind of how people feel about it. And so let's talk about some of those advantages that you would have in one of those battles. Wow. All right, maybe my battery's dead. We can fix that. All right, the first one I think is your voice, right? It's all the things that you can say. It's the way people understand that it's you that's doing the talking. AI has this kind of gravitational pull towards the generic. It's been trained on everybody, so it sounds like everybody. And you really don't want to outsource your voice to AI because you'll become invisible. And that's not what you want. You want to go ahead and let everyone know what your opinions are. You want to be memorable. So instead of prompting AI with a response that you might paste into an email, instead go ahead and give it an opinion. Give it your feelings. Or give AI a corpus of your own writing so that it understands your style, your vocabulary, your way of communicating with people. And that'll give everyone who then reads it a sense that it's you who's doing the talking, because you really want to be interesting, you want to be entertaining, use comedy, be weird, it doesn't matter. Just be yourself, right? That's what you really want to do, because that way you won't be invisible. All right. The next one, credibility. You know, I think when most people use AI, they have a tendency to ask the AI a question, but they don't have a validation step at the end of it. And so the answer, when it comes out wrong, they feel like it's lying to them, it's not trustworthy. And when we communicate with people, we have a different way of doing it, right? We have this whole range of ways to talk and to understand, to clarify what a question means, to give feedback through facial expressions, through body language, right? And so all of those things are you're telling the other person that you're listening. You're establishing credibility by just listening, right? Or if you have a steady track record of success, that's credibility. If you are an emotionally intelligent person who is easy to work with your coworkers, that all builds credibility, right? So that's something that you want, because your credibility, your opinions are important to people, and you want to cherish those, develop them, grow them out. So credibility is a big deal. And AI just won't have that. This is frustrating. Judgment. Judgment's kind of an interesting one. I think, when you are a person, you have gone through as a software developer all kinds of bad design decisions. You've had to mitigate those problems. You've had to deal with toxic managers. You've had to understand what the CIO's tolerance for risk is, right? You have an understanding of what's going on. You have a presence in that room, and you have to understand those things, and they're part of your decision making. AI doesn't have any of those experiences. It doesn't have any of that input. So you need to leverage that as part of how as part of your way of dealing with AI in the world around you. So all of these things are those soft skills that we've all heard about for time immemorial, right? They're those things that we've always valued because it helps you with your human interactions. But is that going to be enough? And I think the answer is no, it's not. Because your value as a software developer comes from your ability to remove barriers, to remove impediments from releasing software. And so you have to think about it in those terms. Now, with AI, 2 years ago or so, we started copying text of our source code and pasting it into ChatGPT, letting it do a refactor, and it did some stuff out, but we would still largely use the same software development process. That didn't really change. It was just one small step back. And I think one of the things we need to do is to change that development process so we get more value out of it, and you become more valuable in that. So you just keep taking a step back. And so the next step back you see people taking is using AI agents. And those will give you the ability to edit multiple files, to call out to the internet, to do all kinds of other things, use MCP servers. So that's a great value, but you get more productivity out of it by taking a step away from the code. So what you do is you just keep taking steps back. Maybe you write an AI agent to review your PR and summarize the changes, because that takes time. Keep taking another step back, right? Write an AI agent that will write end-to-end tests so that you don't have to do all that validation yourself. Take another step back. Write a specification that tells a bunch of AI agents how to work together as a team. And so if you do all those things, you're going to build out a new process that's going to be better at working with AI. And so what you should do is actually go home and do that, right? Because if you do that, you're going to have all kinds of lessons and things that you're going to learn. You're going to learn how to write a specification with markup. You're going to learn how to write an AI agent, or make a container for an AI agent to operate in safely and securely. You're going to learn how to write a spec that runs a company, right? And after you've done all those things, after you've built out that process, then you're going to develop your own voice, your own opinion, right? Having done it, you're going to know that you can do it, so you're going to feel confident. You're going to build up credibility because you can tell your boss, yeah, I did that. And you're going to make lots of mistakes along the way, so you'll have built up a better decision-making process. You'll know how to pivot and use AI in the future because you'll have already gone through those things. And the goal is that you take a very dedicated, thoughtful approach to how you're going to learn how to operate with AI and leverage those unfair advantages that you have, those soft skills. And hopefully you end up like Mr. Rogers, but riding on top of a robot, because that's much more fun. So that's my theory. If you'd like to discuss that on, be sure to flag me down, and I'd be more than happy to talk to you about it.
Thanks, Jeff. This is a three-part presentation. This is kind of a function I had when I was at Rockwell, and I was acting as an internal consultant for business and technology, kind of below the senior staff, but enough to touch the real folks doing the real work. So I got involved in corporate decision making and helping them make decisions. And we had funded a researcher to work in Sematech, which was before any of your times, but it was a consortia of semiconductor manufacturers. And they found a process called IBIS, Issues-Based Information Systems, developed in the 1970s by Dr. Horst Riddle, UC Berkeley. He was a city planner. He coined the phrase wicked problems. He says you cannot write a formula to answer running a city. It would be obsolete by the time it was completed. For a tame problem, you can write a formula and get a correct answer. So easier to do, well-bounded. So he created this, you can step in and move forward. The problems, this is all the decision-making problems that a corporation can have, and I'm gonna just jump through these fast. So all the things that in businesses, there's problems with decision-making. Too much information, subjective, no objective reasons, seldom tracked so you can't reproduce them. Sometimes you delay making decisions because you're paranoid or whatever. Sometimes some employees need to understand why decisions were made so they can do their job better, not just the decision, but why. Communication gaps between engineering and marketing, if anybody's ever encountered that. Problems, companies use consultants. I admit there's a lot of consultants here, but sometimes consultants just give you a PowerPoint response and a report and walk away. The business, while they get the answer to one problem, they encounter those same problems again and again and again. So what we're trying to do with Comstem management tools, and where we started, we're going to capture the decision-making process, leverage past experience, provide an easy way for prioritizing and weighting information. Now, most AI discussions that are out there, they may talk a little bit about values or whatever, but they never expose exactly the values behind every influencing factor, the values behind every possible decision, exactly how all the influencing factors are combined to make a decision, and how each of those combination points yield a pro or con to everything. So problems that we're trying to resolve. We need to be able to explain decisions, and that's very important for where we go from here. After you make decisions and things don't go right, you need to go back and find out why, fix it so you don't have the same problem. So we're gonna give you a process to bring new employees into a business that you're making decisions, they know how to do it. Make it explainable. Again, share decision-making skills, be able to package expertise as templates so other people can solve the same problems. Consulting companies, if they have the way to solve problems, they can build templates and support that with their clients, give them more than just the PowerPoint presentation and report. You can actually give them a template. Say, this is how to solve problems. You still get called back in when you want to upgrade the templates, enhance it a little bit, walk them through it again. Facilitate the decision-making on grave topics. All of these things we're talking about, mergers and acquisitions, featured additions to products, pick a supplier, pick a source of material. All of those are somewhat subjective because you're looking at values. How important are different factors? You need to capture that. Target problems, these I'll just throw up here all at once. We're looking at judgment and reasoning. You mentioned that, and we're gonna put that into our package here for supporting judgment and reasoning in business decisions, and then we're gonna talk about how you can give machines the ability to do judgment and reasoning. Next time. Here's sample problems, and all of these are the correct way we suggest to collect information. You don't wanna say, should I do this or not? You wanna say, what should I consider in order to determine whatever? So everything, you're trying to collect information, you know, this is back to the IBIS days, collect all of the information you can, weigh all the different options, and then you should be able to say, okay, I considered everything. Wicked problems, let's talk about that. Best answer. You need to gather information, no added value, that's kind of the same. Yes, no is the wrong question to ask. You want something to collect information. This is the IBIS structure. Issues spawned by a number of positions or options. You argue the supporting and objecting arguments for every position, and objecting arguments can spawn new issues. In our case, we said positions can spawn new issues for breaking something into smaller pieces. So we violated IBIS a little bit. Assigning factors, awaiting information. How do you collect values? People don't think in numbers, they think in values, like, is this more important than that? You don't think in number 123.3, you know, that you get confused really quick. Answer to soft problems, so the sample is, in this case, that's the best answer. If that's what you're looking for, that's the best 3 answers. So prioritizing tasks. If any of you ever deal with government solicitations, they issue 1,000 government solicitations a week. You want to go in and review all of those manually and figure out which ones you spend your effort going after. That's a challenging problem. We wrote a tool that reads all of them every Saturday night, points out all the top 5 projects that you should go after because of your capabilities, their needs, match it up, focus on the answer. Judgmental activities, project valuation, again, one of the things you're doing is looking for the best things to do. The others is you're making a choice. Now, criteria-driven decision-making is kind of a conventional, that's what you're taught in school. It's called utility valuations, pairwise comparisons. There's several names for it, but you put down your criteria, what's important to you, and then match the options up against the criteria. The other, if you're going to buy a car and you go into a showroom, the salesman is going to show you the features of their car. So it's, what should I buy, a Ford, Buick, or Porsche? Well, I want a Porsche, but I know I need 4 doors for the kids and whatever. You know, you gotta play games with that. But those are the kind of decisions that we support with CMT. Anything, there's a database behind this, so this is a database tool. Everything's captured in the database. Templates for problem solving. You create your own templates. We give you a very simple template for all problems and all arguments. So it's kind of like a general template for both positions and arguments for every problem. That's not really what you want to do all the time, but if you're just getting started and you want to solve world hunger on your first day at the job, then you can do that. We give you a template for that. All the rest of the templates you have to do on your own. Our user interface, since I've been using this since approximately this process, not in this version, probably since 1985. I've collected every problem that anybody's ever given me, and I've worked in mergers and acquisitions, project selection, feature selection, even collecting code samples in here. So everything falls in there. Those are file drawers. So you have file drawers for collections of issues or problem spaces. That's the database name, file drawers, database search, so you can search about, so you did some study at some time, you want to find it, you don't know what file drawer it's in, you can find it. Start a new project, gives you that entry, and you put a title in there. You can, this is just text describing your problem or your piece of information. And what we have in this case, a prompt help. And this is again to focus you on stating your problem statement correctly. And so here's our prompt page, and it says, you know, the ones under right are the right ways to ask the question. There's a couple wrong ways, don't do that. But it gives you samples, and it'll actually give you the start of your sentence in the box. You fill in the rest of it. So what options should be considered before that? Then you save it, and you enter the drawing mode. So we're collecting this decision or information tree in a database, graphically shown on the tree. Add positions or add using templates. So here we have templates, and you pick a template, and there you choose the potential things to consider. So compatibility with core competencies, skills, operational resources. And this is our general template, so you can answer any problem with this or work it through. Put some different ones in there, and then you can add decomposing questions automatically. So if you know the compatibility with core competencies, and you check the other one, it's going to show another box below saying, okay, how do I segment this topic? So you're building this template format rapidly, execute, And all of a sudden, now that box, and this just has the top layer, doesn't have the breaking down of the options. You select one, we're gonna go there, we're gonna add arguments, add templates. We have a template management for the pros and cons. You can use these arguments, again, they're all just stated there, arguments that you're gonna have to wait. So you're gonna just collect these. And this is an area, oops, let's go back here. Okay, and where's the mouse? There's the mouse. Okay. This is how we do ranking and weighting. So there's the ranking, you're sliding them up and down. And what's happening, you haven't gotten to the numbers yet. Slide this down, notice that it pushed all the ones below it to a lower number. If you push something up, it forces the ones above it to a higher number. I've used this with senior management when they're trying to prioritize things for a 20-item list, and this can go on for a screen width. I've had a guy work 4 hours on a 20-item list, ranking and weighting. So he had actually thought about the problem, what's important to his business. So this is just, so now I have my arguments assigned to each of my positions, and select the top level. It'll come out and say what kind of a analysis do I want to do, and pick the one, and you get a report that looks like this. Let's see where you get tornado charts that actually show the numbers for all of your arguments in here. So up at the top, at the very top, it gives, this is your problem, this is the answer based on your weighted values, and here's an explanation of all the things that you weighted and valued, and what you get with your senior management, if they want to query, look at something and say, well, this value isn't quite right, should be more important or less important. You can adjust it on the spot, regenerate the report. He's now bought into the solution. That's his value system that has been accepted. So the reports, everything's documented, everything's exposed, collected value information. Oh, this is one thing. We're dealing with judgment and reasoning now, and it's not averaging. We're collectively processing information just like a human brain does. It doesn't average numbers. It uses these pros and cons, and if you're solving multiple problems at the same time, and say cost may be something that impacts two problems. Maybe you have to solve both of them at the same time, but you allocate resources across both of them. So you actually have to consider how applying all your resources here, well, that totally stops your other program. You can't do that. How can I balance the resources appropriately across multiple applications? So time, money, and all kinds of things. Impossible overrides must. So you have two managers. I don't know if anybody ever had two managers. One guy says go left, and the other guy says go right. Okay, well, or one guy says, I want you to run over here into that room, and the other guy says, I want to run through that wall to that other room. Well, impossible overrides must. So if two guys have equal authority, and you have to break a tie, we say no overrides yes. So the way we actually accumulate the information is we accumulate all the driving information, and then we do it essentially by a law of diminishing returns. If you have two pieces of information, each weighted 50%, do it. The first one carries 50%, the second one carries 50% of the remainder. The third carries 50% of the remainder. So even if you have multiple things weighted the same, you're just accumulating up to 100% of yes. If one thing's at 100% yes, okay, you can start looking at the negatives. Then if one says 10% no, another one says 20% no, and one says 100% no, that's impossible. Impossible overrides yes, so all you've accumulated goes to zero. This is the collective processing of information. We got a patent for that. This is the senior management probe for weakness. Regenerate the report. client buys into the process, it's their value system and whatever. So in summary, CMT is a tool, can run on personal computers, PC or Mac, helps humans making decisions. There's the presentation if you want it, that's the link to the whole presentation. Everybody want it? And from our standpoint, this led to the development of Keel technology. And depending on time, that's presentation number 2. We have our own version of AI that targets machines that think. So we're looking, and you had your picture of the Terminator up there. Well, we started our work in CMT at the same time Terminator came out, and we thought about, well, because I had looked at factory automation and identified that machines did not use judgment and reasoning. It just followed rules, relay ladder logic and if-then-else stuff. And they did not have judgment and reasoning capabilities. And I highlighted that as a issue for manufacturers. And now I figured that we had a way to address judgment and reasoning in a machine, and that led to the development of Keel. And that totally changed our space because the Terminator, and we started talking to military, PEO Stride, which is the Army's evaluation sensory, I don't even know what it stands for, but they have an extremely large laboratory in Orlando filled with robots. They have simulation systems of everybody. So you can bring snipers in, run them through a simulated test range. You can have robots fighting wars. You can have all kinds of simulations going on. And I presented what we first had to them, and it's a different language, a graphical language, but they have all this stuff moving around. They said they want to see stuff move and see it think in real time. When we started building that, finish here, and here, find my next presentation. And we'll give you a really quick one on the next time, because I want to take everybody's. All right, so start off, wicked problems, heard that before. That's where we started in the 1990s. That's what we did, started the business unit. This is the feedback from the customer, said if our software was so good, why didn't the software make the decision? Good idea. CMT is, that's what we showed you, what CMT can do, application areas for CMT, Rockwell, that's where the name Knowledge Enhanced Electronic Logic came from. I was actually asked to write a report on that. So at this time, Terminator, we had a way to start reasoning. That was our starting point. So from CMT, we used the term positions and had an importance value. So in our new language, which you'll see in a little bit, everybody's seen a vertical slider bar chart. And you know that a taller bar is more important than a shorter bar, or most of them do. So that way we show values vertically. And we have supporting and objecting arguments. And arguments in our new language are sliders. So when it has a green triangle pointing up is a supporting argument, and a red triangle pointing down is an objecting argument. So you have an interactive language where you can move the sliders up and down and see values change. And the graphical language came about. After a series of patents, we realized that we were doing an analog balancing act. So back to the throwing a rock in the middle of the pool and having all the molecules figure out where to go, they're all balancing forces from the outside and exactly deciding where to go. So when you're using judgment and reasoning, solving multiple problems at the same time, you're balancing in your head with all those forces on the different problem spaces and all of your influencing factors. That's what's going on in there. I don't know how it's working in the human mind, I do know how it works in Kiel. So, what we do, so we did started, oh, we said that we didn't want to be in the architecture war. So in factory automation space, Rockwell was competing with Siemens and General Electric and 5 or 6 other major players in the factory automation space all over the world. And those were major wars trying to collect all of the clients of the world into your pile. That's why everybody wanted to have their own architecture. OPC kind of came along and tried to give a general architecture to everybody, but not everybody's supporting that. I didn't want to do that, so we wanted to be platform, we wanted to be application independent, platform independent, and system architecture independent. So we don't care if it runs in the cloud, runs on a PC, runs in a mainframe, runs in an edge device with an 8-bit controller. We didn't want to care. So thinking in curves, when you're actually using judgment and reasoning and responding to real-time events. You know, we've been asked to supply, which we did not, we've been asked to supply our technology to the Ukraine. And we have told them that the only way we do that is through a major prime contractor that would handle all the security issues and whatever. Because with this technology, we think you could compete with anybody, anywhere in the world, because you're looking at real-time autonomous, self-organizing systems. This is on our website. Let's see if I can just, where can I see? Here, play. Oh, yeah. Well, if you go to our website, it's our #1 demo. You can have the little planes flying around. The red dot, the big red dot is the target. There are little red dots that are defensive mechanisms. You have 2 UAVs, you can try and fly them into each other, they won't do that. They're smart enough for that. The little ones over the side, we have embedded frustration into the UAVs. So if they try to find a safe way to attack the target without getting too frustrated, they will do so. However, if they get frustrated, they'll go home and say, I don't want to play anymore. That's what drove us really to focus on explainable AI, because I have my little planes flying around, and all of a sudden they look around and say, no, I'm going home. Why did I go home? Well, target value, risk, and my weapons supply that said, well, probably not appropriate use, go home. And so the UAVs do that. We actually show you the values up here that they're thinking about. Each UAV has its own Kiel engine in it, deciding where to go, how to make collision avoidance decisions, how to evaluate the quality of the target, and how to evaluate the risk when they're getting threatened by outside sources. And then we put human on the loop. So we allowed a human on the ground not to take over remote control, but to say, well, that target's more important than you think it is. The UAV has some intelligence that says this target is worth this much, but now you know more. You on the ground, you can tell the machine, well, we're not taking over remote control, but we'll tell you that your value system is off. I want you to be more risk tolerant, and I want you to take on more risk, and instead of getting frustrated, you'll go diving right into the target. So quickly, basic life, he's balancing fuel, air, put human on the loop, outside the loop. So this is human on the loop control, or because the human can add value by putting information into it. The human outside the loop created the policies to how to interpret all this information, and he's tested it within the language and simulation and whatever. And then you know, the human outside the loop is a fully autonomous system where humans just sit back and let the machines do the job. May happen someday in some things. Language animation is something that we added to the technology. So the UAV, especially when you're running in simulations, so you're running these in complex simulations where you have hundreds of drones, bunches of teams or squadrons, all working together to for the battle space, and we wanted to be able to watch a UAV think. So what we have is the ability of the UAV to publish essentially as an XML file or a JSON file, and it publishes what it's seeing, and if you collect that back in your development environment, you can actually watch the language move. And essentially it's something that you can say, well, why, my first one was, why did you go home? You know, and oh, well, that's appropriate, okay. So, Teal's been used in many areas. We got stuff, we work with the medical college in diagnosing anemia in adults, where a pathologist has to look at like 250 combinations of values of blood tests to make a diagnosis. We worked there with the lead pathologist, and he gave us some HIPAA cleared data for testing, and in the end we disagreed 4% of the time. So what we did to add, there's a demo on our website, it's now used by hospitals all over the world to check their diagnosis. You can enter the data and it will say this is a test case, but here's the suggested diagnosis, and then there's an option that says, well, explain why it wasn't one of the other ones. So you can now push that and it'll explain, well, you made this decision and maybe you were wrong. So the pathologist at the medical college's response was, well, so I call that the O analysis. So it's 100% explainable diagnosis again. This is that demo. The red bars on the right side are the explanations of why those different diseases of anemia, types of anemia, were not detected. We've demonstrated that these Keil engines can run on an 8-bit controller. All of our languages, I think we output in 55 different programming languages and IDEs. Runs a little Arduino, so if you've got your hobbyist helicopter, I bought a $2,000 one back when they were really expensive, just to verify that we could put our judgment in there. Again, 3 types of decisions that humans make: go, no-go decisions, mutually exclusive option selections, door A, B, or C, can't do more than one, or allocating resources, do so much of something. So those are the kind of decisions and activities we're doing with Keil, and we're doing it in real-time environments, so we're talking milliseconds. Our code for solving this kind of interesting number, we can solve all of human judgmental problems in the world with 8 pages of code. So that's kind of our claim to fame, because the problem space is maintained in data tables, not in code. So the code just processes the data in the data tables. So that's kind of a PLC kind of thing too. We also support like IEC function blocks. So if you have a big problem, you want to break it into pieces, then we create function blocks, and you can put Keil engines in function blocks, and this wires them all together. Keil Reviewer is a thing where you can store a bunch of snapshots of information from your UAV when it's going to work, and come back and then play them one step at a time and watch the information change until you make a decision. And Keil Influence, this draws conventional influence diagrams if you want to show this to a high-level management about what was considered and what's influencing, so it draws the balls and the arrows. We have a self-organizing swarm example that was interactive too. Some of our demos are just videos now. We did everything in Flash before, but then Flash kind of got the bad rep, so I had to redo some of them in HTML5. Keil Engine's autocode, but the rest of the graphics and stuff will work. There's languages. I don't think this is even updated. It isn't, because we have Python inline class, which will auto-generate a MPC server. Rust isn't showing up there. So when you're putting a Keil engine together, it's got a simple API. You load normalized inputs into an input table, call it to go think, and then take the outputs out of the output table. That's pretty much if your system can support that, you can put a Keel engine in there. Where our training on Keel is done in 2 hours and 18 classes, 3 minutes to 11-minute classes, I think. You take 2 hours, you can program in Keel. We suggest you play for a couple weeks, learning all the other tools, and then go on SolidWorld Hunter or whatever problem you want. Humans separated from computers has been the judgment and reasoning capability. Machine learning, pattern matching is not really judgment and reasoning, it is pattern matching, period. At least as far as I'm concerned, people can try and argue, I'll still wait for arguments, but you don't expose the value system behind every factor. So our argument that I've used consistently is, if your system can't explain all of the options that were considered, how important those were assigned to your problem space, all of the influencing factors, some of which could be used by both problem space at the same time, and how important every input influencing factor was to this problem space, and then how all of the inputs are integrated together to drive the outputs. If you can't explain all of that, humans can't do that. But if you model policies, behavioral policies in Keel, your system will do that, and it's explainable because you can learn how to audit a Keel language